Hello and welcome back to graphing rational equations. We've graphed our vertical asymptotes and we've graphed our horizontal asymptotes. The next thing we want to graph are our x-intercepts. So let's go back to the first problem on the worksheet and graph in those x-intercepts. An x-intercept is going to happen anytime y is equal to 0 because that puts us on the x-axis. Well, anytime we divide 0 by anything, that's going to be equal to 0. But our numerator here is 3. And 3 is never going to be equal to 0. In fact, there's nothing I can divide 3 by that's going to give me 0. Well, if y can never equal 0, then there are no x-intercepts. Let's take a look at our next problem. Once again, I have a constant in the numerator, and 2 is never going to be equal to 0 either, no matter what I divide it by. So that means that once again, I have no x-intercepts. Let's move on to problem 3. Here, I have an expression including x in the numerator. So I can set that equal to 0 to find out when y might equal 0. I have negative 3x minus 3, and I'm setting that equal to 0. I'm going to solve for x. I can add 3 to both sides. That will give me negative 3x equals 3. Divide by negative 3, and I get x equals negative 1. Well, that is my x-intercept, and I'm going to sketch that right here on the graph. Let's go on and take a look at the fourth problem on our example sheet. Once again, I have an expression including an x in the numerator, and we have handily factored this already. Just like when we're looking for the not allowed parts of the denominator, if I set either of these factors equal to 0, then I'm going to get 0 in the numerator, and I'm going to get an x-intercept then because y will equal 0. So if I set x plus 4 equal to 0, I have x equals negative 4, and if I set x minus 4 equal to 0, I'm going to get x equal to 4. So those are my x-intercepts here at 4 and negative 4, and I'm going to sketch those onto my graph. So next up, we will be sketching these graphs, but that's all for x-intercepts.